we have talked about systems of equations. We have discussed that they are systems of equations that have at least two equations, so more than one equation. So we're working with two equations at least, which on a graph would mean more than one line, so at least two lines. And we also discussed that a solution to a system of equations is where those two lines cross, or their intersection. So if I want to solve a system of equations, I find out where the two lines cross, and that coordinate pair, or that ordered pair, that point on the graph, is my solution. Now, one thing we're going to run into, though, is the fact that sometimes you can have different solutions. You can have a different number of solutions, all right? And the graph, as you can see in this line up here, the graph of a system of equations shows us the number of solutions, okay? So basically, here are your options. You can have no solution, you can have one solution, or you can have an infinite number of solutions. Now, the one that we've been working with, the two examples previous, in the previous two videos, were examples of one solution, okay? So that would be where you have two lines that cross each other in one place. And as you can see, this graph up here on the right would be one solution. There is one point where these two lines cross, and so there would be one answer, and that is the point 2, 3. So what about these other two graphs? Well, remember that the solution to a system of equations is where the two lines cross. Now, if you notice down here in this graph, we have parallel lines. And one of the definitions of parallel lines is that they never cross. And if they never cross, then by definition of a system of equations, there can be no solution. So two parallel lines have what we call no solution. Now this next graph, the one in the top left here, this one's a little bit tricky. And why is it tricky? Well, it's tricky because I've got two different equations, but what appears to be only one line. And the reason that it's only one line is this is actually two different equations with the exact same line. When we graph those two equations, we end up with the exact same line. So in essence, it is one line right on top of another. And when one line is right on top of another, then their points are touching all the way up and down the line. There always have points that are crossing or are together. So what we call this then is infinite solutions. So this would probably be the most rare option, but if you happen to end up with two lines that are on top of each other, then we call that infinite solutions. Okay, so let's see how well you're paying attention. Here's another example. Here we have two parallel lines. What did we say about two parallel lines? Well, two parallel lines will never cross. And if they never cross, then by the definition of a system of equations, they can have no solution. So get used to seeing parallel lines and thinking no solution. What about this one? Here we have another example where it appears to only have one line, but there's two different equations, which means we have one line laying right on top of the other, and we would call this an infinite number of solutions. So just to recap, the first two examples of systems of equations, we had lines that were crossing, and they had one point where they crossed, and we call that one solution. Parallel lines are going to be no solution. One line on top of another, we're going to call that infinite solutions. I would like for you to take a look at the Got It on top of page 237 and try this for yourself.